this episode, we're diving deep into Vietnam's boldest infrastructure project yet, a 1,541-kilometer high-speed railway connecting Hanoi in the north to Ho Chi Minh City in the south. What makes this truly historic? Vietnam wants to build it, largely with its own money, its own engineers, with technology licensed from foreign companies. Off one of the most complex rail projects in the world? The government thinks so. Project overview. Estimated total cost, a whopping $67 billion. Length, 1,541 kilometers. Speed, 350 kilometers per hour. Stations, 23 passenger stations and 5 freight train stations. Construction breakdown. 60% elevated, 10% tunnels, 30% ground level. Travel time. Cut from 30 hours by current train system to just 5.5 hours.
Good morning,
Good
Mr.
morning.
Tien.
Good
How are
morning.
you?
I'm very well, thank you.
Timeline. Begin in 2026. Complete by 2035.
UTC is piloting a 5-party cooperation model. The state as a policy architect, businesses as market drivers, universities as talent and knowledge creators, technology transfer units bringing innovation, and local communities as direct beneficiaries. This approach will not only build trains, but strengthen Vietnam's industries, boost management capacity, and drive sustainable economic growth. From Japan's pioneering Shinkansen to Europe's competitive networks, the world has shown the way. Now Vietnam is ready to write its own high-speed rail story, one that connects cities, empowers communities, and moves the nation into the future.
Hello everyone. This is Akulina. You are watching Coffee with Lina podcast. Vietnam's high-speed rail project is an exciting step toward modern, sustainable transportation. But the project also comes with some big engineering challenges. Let's listen to some information regarding the project from Dr. Tien, who is the Dean of University of Transport and Communication. Good morning,
Good
Mr.
morning.
Tien.
Good
How are
morning.
you?
I'm very well, thank you.
I think lately you are very busy with the railway project. Can you please introduce yourself to our audience?
Yes, I'm Professor of Civil Engineering from the University of Transport and Communications.
Communication. Thank you. So, for the high speed railway, so many things are ongoing. So, I'm curious to know what innovative engineering solutions can Vietnam use to reduce land acquisition for high speed railway?
Yes, it's very interesting question, and I would like to go a little bit further back because let's say Vietnam is very long countries,
Yes.
and so the livable land is along the coast, and most of the people live along the coast, and our high-speed railway line north-south is near the coast, so we have to move to very densely populated areas, and also we have mountains, and we have subsoils. So let's say it is, let's say it's not conflicts, but it is something, it is a geometry constraint.
Yes.
So that land acquisition is very important for this such important projects. On one hand, you have to connect different populated area,
True.
but on the other way around, we have to, let's say, to find the harmony and to avoid obstacles. So that one of the first solution is to use the elevated structures and tunnels. And actually, more than half of the total land with the section is elevated structures and bridges. and tunnels, so that we don't conflict with the land.
Yes.
And then the land can be agricultural land, because it is we have a rich soil, because along the coast we have, let's say, every 50 kilometers we have an estuaries, rivers, and then we have a very good land for agriculture. So by using elevated structures, we can save the land, so the land underneath is still for agriculture. So it is we take some challenges.
Yes.
Because as you can see, because we have to says one of the engineering solution is to combine bridge with different function. For example, let's say a motorway bridge can combine with a high-speed railway bridges. Why is that? Because let's say to build infrastructure, we have to build support structures. That means we call it substructures with piers and foundations. So with the elevated structures, we have to, or the combined bridge, we can only have to build, let's say, one system of substructures, and then with the lower deck we can mobilize for motorways. The lower deck can mobilize for railways. So that it is engineering choice that we have to make. So that let's say different kind of innovation, but let's come first with the structure side. Yeah.
Yes, definitely. It's true. Vietnam's geographical location is really challenging for the railway,
Yes.
high-speed railway, but definitely you have to use it wisely. Many meticulous engineers are working behind it.
Yes.
Definitely they will get the success. How do electric multiple units or EMUs affect track design, power supply, and maintenance needs?
Yes, it is actually typical in the world. There's two systems. One system is how can I say, the traditional locomotive system. So there's the train sets. Let's say it is have one locomotive or two locomotives at either end of the train set. But for Vietnam, EMU is more preferable, because let me break down different aspects.
True.
First of all, let's say our system is combined system. That means one function is for passenger, and the other function is for freight or cargo train. We call it event-based loading. Most of the time, it will use for the track is used for passenger train, passenger only. But sometimes in some certain event, we allow the freight train to run on the track. So that let's say the EMU system is a distributed system, and we can call it parallel system, like parallel computing in computer science now. So with the parallel system, we can reduce axial load, and reduce axial load, we reduce the traction. So we reduce the pressure on the structures, so that we don't have to build a very steep fastener, and so on and so forth, especially for the train. So it when running very fast, it creates a lot of lateral force. We call it track hunting, or the train hunting the track, so that it creates a lot of force on the track system. So that the EMU is more, let's say, suitable, because the traction is along the train set in every carriage. And secondly, it is let's say people is very sensitive to lateral movement, so that
Right.
so that with let's say with EMU, so the traction is everywhere. So that's the traction everywhere. It will return the reduce the, let's say, the lateral movement, and also for braking, and let's say EMU is more efficient. Last but not least, Vietnam is a very humid country with a lot of rain. It's not like in France. France is very dry country. So with the wet atmosphere, so the traction is everywhere, which will create the efficiency for the system. So in short, let's say everything, most of the thing in life, parallel system or distributed system is more, let's say, suitable or more advanced rather than concentrated system. So that's why we use electric multiple unit rather than the traditional locomotive system.
Yes, that's really the wise decision for the Vietnam and government, because you are thinking from the different aspect too, different perspective about the weather, about the requirement of the passengers. When you are not using that for the passengers, for the different purpose, you can use it as a freight train. Oh, definitely, it's a good initiative too.
And I would like to add little bit technical details, because the EMU is physically more efficient, more optimized than the locomotive system.
One.
And in that sense, let's say we already think, let's say we already make some comparison. Otherwise, if we use a locomotive system, so the actual load could be, first of all, let's say for the EMU system for passenger train, the actual load is about 17 for 18 tons per axle. But for the locomotive, some axle can have much more load, perhaps 22 to 23 tons per axle. So increase in the weight will create exponentially increase in traction and in pressure on the track. So that let's say by very small comparison, you can see that the EMU system for Vietnamese condition is much better
than the other system,
than the traditional locomotive
one.
system.
Yes, definitely. How do gentle curve requirements influence alignment choices and overall project costs? Depends upon the cost also. So
yes. Actually, we talk about two costs. One is construction cost, and the other is the maintenance cost, and we call it life cycle cost, because one project is by our law is 100 years. So we have to take 100 years into calculating the investment cost. Let me explain why. Because for gentle curve, let's say the traction, as I mentioned earlier, the traction could be smaller on each carriage, so that the system is lighter. That means we don't, let's say it's less stress on the infrastructure system, that is the track and the substructure under the track. So that's the gentle curve. And also again, it is people comfort, because eventually the train is to moving the passenger,
taking the people,
and the comfort of the people, the passenger is very important. So with very low ratio, we can create a very high lateral force. We call it centrifugal force under high speed, right? And as I mentioned, the lateral movement will cause, let's say, discomfort to the passenger. And also for the maintenance, because let's say the lateral force is too much, gentle curve is much more efficient than the let's say low radius curve. So that for the long term, for the life cycle cost, I believe that the gentle curve is more efficient. Last but not least, it is about the thing that we also have to consider is the technology. We call it tilting train. That means when you design with very low radius curve, and normally we have to change the elevation of the two rail on the track, so that for the train we have to use the tilting train. That means the mechanical system that makes the trail tilt when come to the curve at high speed. But our system is multifunction. Sometimes we use it for event-based loading. That means we use for freight and cargo train. So the cargo train have to be to run very fast in order not overturn. So that let's say gentle curve will solve the problem of train overturn by let's say more level is the same elevation between the two rail on the track, so that it create a different
feeling.
Different advantages. I know that some country like Germany, they use tilting system to combine both the freight train and the passenger train. But I think for our choice, I think it's better to use a gentle curve. Even we know that the investment cost for construction could be higher than the investment cost for let's say lower radius curve.
Yes.
And also, let's say we built our system is newly built, and let's say German and France system, sometimes they upgrade from the current normal train into high-speed train. But for our situation, we will build a separate new high-speed train, high-speed line, so that we the better to take with the center curve. That means very high radius curve. One thing we should also consider is that we intend to design the track to sustain 350 kilometer speed of the passenger trains. But for country like in Japan or in China, now they are already thinking to, let's say, increase the operating speed to 400 kilometers per hour. So if we have a gentle track, we have, let's say, room for increasing the operating speed later on.
It is reminding me the roller coaster. Sometimes I see the people they are eager to experience the roller coaster, but so many things are there behind, because you are talking about gentle curve and the low profile curve, right? So gentle curve is more comfortable for the passengers and their safety too, because about the centrifugal force you are talking about. So be careful before experiencing roller coaster. When they are, a lot of engineers are working behind it, high speed railway, about the centrifugal force and how they can be useful for the passenger. So it's really
it's a very, very good example, because roller coaster is for human experience.
Yes.
Let's say the teenager would
adventurous.
like to, very adventurous, and they would like to create some experience,
excitement also.
Excitement that they never been to before. But for the train, people need to safety, comfort, because let's say on high-speed train, people can work with high internet, with computer, you can comfortably work. And there's let's say there's stats that people just put the coin, let's say on the side on the train, and it run along the track and without falling down. So it is, I can say, it is very, very comfortable, and stable inside the train, so that you can work, you can enjoy music, you can prepare your best for the chief. That's very interesting.
Recently now in India, Vande Bharat train, they are trying to use the same. They kept 3 bottles on the top of the each other, and it's stable. When the train is like, you can understand the stability of the engine and the curve also, so stable.
Yes.
Mm.
So that is a similar story before. Let's say we use a highway from the north to the south. We put a cup of coffee and the coffee spin everywhere. But now with the
No spillage of
motorway,
coffee.
yes, with the motorway system, with a, let's say, very smooth and gentle curve for the motorway system, so that we can enjoy the coffee.
Yes.
Among other
At
things.
the time when you are traveling. When do the benefits of elevated tracks outweigh their higher construction and maintenance costs?
Yes, I think let's say some country like Japan, like China, and like Vietnam, we have let's say we have soft soil. Let's say close to the sea, we have soft soil, and let's say on that condition, the elevated system or elevated structure, elevated viaducts is more efficient than the let's say traditional let's say honor system. Let me tell you why. Because for high speed train, that means the train run at very high speed.
Yes.
So that the precision is very important. So we talk about millimeter of precision along hundreds of kilometers. So in order to create such stabilities, you have to better use the, let's say, elevated system, so that the, let's say, the track stiffness, so structural stiffness is stable along the way. So for in that sense, you use elevated structure, you can, let's say, have the same stiffness along the track. So again, it can create, let's say, stable and also more comfortable for the passenger. Second thing is that because as I mentioned, Vietnam is people live along the coast, and we have a lot of rivers, every 50 kilometer rivers, so that if we use embankment sometimes for the substructures for the track on Earth, we have to use embankment. So embankment will create, let's say, will prevent the water flow during flooding, so that it create more flood. So as you can see, or the last year there's a lot of flood in Vietnam. So the elevated structure is how can I say, it is geometrical, let's say, different. So we separate two systems, and the one system, it doesn't affected by the flood and by the water underneath. So that is very important. And also, let's say, for the high-speed train running at high speed, it is dynamic behavior or vibration is very important, especially the resonance. So that with the elevated structure, we can design exactly the length of the girder, for example, 30 meter or 35 meter or 40 meter, to prevent resonance at certain speed, so that we have more control of the tracks. So elevated structure is much more advanced than the traditional substructures that we use. I would like to talk a little bit about technicalities. That means for design limit state for normal structure, let's say for motorways, or normal train, we just check for strength limit state. So the strength limit state is dominant. So first we check with the strength limit state. But for high speed train, service limit state is very important. It's much more important than the strength limit state. So we have to check for the strength. Sorry, for the service limit state. That means the deflection, deformation, vibration, and so on and so forth. You can imagine if the structure, let's say, on the ground, so the earth is flat, right? And then the movement of the track, when the train passing by, will create, let's say,
less
settlement,
vibration.
vibration and settlement. so that you cannot operating at very high speed, or otherwise you have to reinforce the track permanently. That costs a lot of maintenance cost. So that it is more advanced using the elevator structure. And last but not least is the settlement of the track. So with the elevator structure, we have we would depend on the deep pile foundation. So it's much more stable, and no settlement, almost no settlement along the service line, so that we don't have to pay a lot for maintenance costs. Whereas with the traditional method, you have to invest a lot for maintenance, and sometimes it costs the stop of the train, because you can sometimes with let's say with big maintenance, big repair, you have to stop the train, so that it will even create more pressure for the transport network.
Yes, I see that. Like the engineers are thinking about the advanced system and low cost maintenance also.
Yes.
Both.
Yes.
Number 5, how can Vietnam build its high speed rail in a way that supports sustainability?
Yes, this is very important, because sustainable is everything we have to talk about now, not only Vietnam but globally. I think for sustainability, I think it's very important that we have reliable source of power, electricity. So that is very important. And then we let's say we are building let's say electricity power power station to not only for train but also for industrial growth, because we said in our CPC number 14 that happened here in Hanoi. We set the growth rate 10% increase in growth in GDP annually. That is very demanding. So we need a lot of power, a lot of electricity,
Right.
And then the train needs to be very stable. So we have to need a lot of investment, a lot of growth in economy, in industrial growth, in transportation growth, infrastructure growth, in almost every aspect of the life. So that sustainability is very important. Sometimes could be we have to plug our systems, our electric system, to neighboring country. That means we can buy the electricity from other countries to, let's say, to sustain our development. So that is overall pictures. But for transportation, for infrastructure is very important, because the logistic system cannot be disrupted if we would like to sustain very, very demanding GDP growth. So there's a lot of technical, let's say, technical solution inside. But let's say everything have to care about sustainability development. Also for the operation and maintenance is also very important. That's why we talk about elevated structure, we talk about gentle curve, we talk about combined bridge that is used both for train and motorway.
It is a true example of Vietnam government and the technical expertise of University of Transport and Communication, all engineers and the innovative solution makers.
Yes.
It is an example of aspiration, desperation, and inspiration also. Cost, maintenance cost, and the project cost.
Yes.
So many things are ongoing behind the scenario of coming high-speed railway in Vietnam, which is new, really exciting thing for the government, for the people, and definitely who are working behind it. So I would like to conclude my conversation with Mr. Tien, who has shared a lot from his technical expertise about the high-speed railway, and who is working really meticulously with all the engineers here. Definitely, we can see the success in the future.
Yes. Thank you very much. And I would like to wrap it up with efficiency. As you said, is very important. So for efficiency, I think the best thing is we have to let's say we have to take the core technologies. We have to develop the core technology. Of course, the first step is like flywheel. We can, let's say, learn from other country with a lot of experience in high-speed railway. And then we can learn from them, and we start step by step to take over the core technologies. Only when you can understand very well and you have a full control of core technology, you will have the control of maintenance and operation, right? And also to expand the network, because now it's a north-south high-speed railway, and then we already have semi high-speed railway from Hanoi, Haiphong to the border city of Lao Cai. Or then we have connection from Ho Chi Minh City to other part of Mekong Delta, and so on and so forth. So to master the technology, to know the core technology is very important. And then for university, we always think that that's a human capital is the main point. That we have to build a very good curriculum. We have to learn from other countries. Our university professor can go abroad to study, or otherwise we can invite, or let's say, good expert, good professor, high-ranking professor from other country to come here to help us not only with the high-speed railway design and construction, but also other technology like digital transformation, energy efficiency, so on and so forth. So that our university mission and core value that we would like to take it, and then already now we already have a high speed railway engineering program that attract a lot of talent and students from all over the country.
Oh, that's
Yeah.
great. That's great sharing. So if you think our video and our information is really valuable, please like, share, and subscribe my channel. And definitely do not forget to comment in the comment box about the video. Back to you.
Yes. Thank you.
Thank you.